Alright, so now let's look at question number 1. So this question is the final examinations for semester 1, session 2021-2022. Okay, you can refer to these final examinations in order. So in this example, we have to use the partial differentiations, okay, to determine the expressions for del y del x. Okay, in the following case, okay, we have 1 and 2 over here. Okay, so del y del x meaning that you have to do the partial differentiations. Okay, so we look at the solutions. Okay, so this is question number 1. So I will write down here as this is the final examinations for the semester 1, 2021 and 2022. Okay, so question 1A. So you are required to find the del y, del x. Okay, this is your job. You have to find this one. So let's look at the first questions. The first example is this x power 3 plus y power 3 minus 2x squared y equals to 0. So you have to find the del y del x. So usually when we want to find the del y del x, we will make sure the y to be on the left side and the other parameter at the right side. But for this case, you cannot split. Okay, you cannot split the y from the x. Okay, so here we have to use the we have to use the implicit, okay, implicit partial differentiations. Partial differentiations. Okay, since we want to find the del y del x, okay, the formula for this implicit partial differentiation will be negative fx over fy. Okay, fx over fy. So now let's look at what is our f. So our f is x power 3 plus y power 3 minus 2x squared y. So this is our f. So our fx, okay, will be 3x squared, okay, minus 4xy. Okay, find minus 4xy, yeah? Right, so our fy will be 3y squared minus 4x squared. Okay, so this one will be our fy. Okay, so when we put them together, negative fx is 3x squared minus 4xy divide with the fy. So we have a 3y squared minus, oh yeah, this one I made mistake. This one I made mistake because it's y, right? So it should be 2x squared. So it's 2x squared. Okay, because I differentiate with respect to the y. So this one will be your final answer, okay, for the del y del x. Okay, we go to the question number 2. Okay, question number 2 is to find the partial differentiations for the sine square x minus find sine x cos y plus the tangent x equals to 0. Okay, so same case like the previous question, you have to solve by using the implicit. Okay, so this is the formula del y del x. So negative fx over fy. So our f in this case will be sine square x minus 5 sine x cos y plus tangent y equals to no equals to 0. Okay, that's it. Okay, so for this one, right, okay, you see here we have the sine square x. So for this one we need to apply some identity, okay, so that later on the calculations will become easier, okay, when you want to do the differentiations. Okay, so for this sine square x, you could rewrite it to be 1 minus cos 2x over 2, okay, over 2. Okay, and then we can apply this thing, okay, into the f formula. So it will be 1 over 2 minus cos 2x over 2 minus 5 sine x cos y plus tangent y. Okay, plus tangent y. Okay, so we can start to find out what is the fx. Okay, so the fx, so here it will be, this will be 0. Okay, it will be this 1 over 2 you can take out, so the cos become negative sine 2x. Okay, and you have the 2x, so here you have an extra 2. Okay, and minus the, okay, 5 cos y will be the constant, so you write it out again. Sine x will become cos x, and the tangent y, okay, is a constant, so it will become 0. Okay, you can cancel this thing. You can cancel this thing. And fy, fy on the other hand, this one will be 0. Okay, and also 0. And 5 sine x will be a constant. Cos will become negative sine y. And the tangent y, okay, you can refer to the table. Tangent y, when you perform the differentiation, will become second square y. Okay, next is to put them together. So we have the sine 2x minus 5 cos y cos x divide, okay, divide with this, okay, negative 5 sine x negative sine y, or if you want to combine them to make it to become positive also can, right, and then plus second square y. Okay, second square y. So this one will be your answer, okay, for the question number 2. Next, we look at the question B. Okay, question B is telling us that if the z is equals to xy over x minus y, we have to show that, okay, we have to show that the x square, okay, and the del square z over del x square minus y square del square z over del y square equals to 0. Okay, so this is question 1 B. Okay, z equals to xy over x minus y questions. So we have to prove x square del z square over del x square minus y square del square z over del y square equals to 0. Okay, so this also means that we need to find out these two terms. Okay, these two terms we need to find it out. Alright, so we have to use the rules. Okay, we have to use the rules. Either is the quotient rules, okay, or the other one. Okay, so you choose the rules that you want to use. Okay, so z could be write as xy and x minus y, a negative 1. Because I want to use the product rules. I want to use product rules. Okay, so the del z del x will be xy, and then negative x dollar y minus y, negative 2, okay, 1, and plus y, x minus y, negative 1. Okay, so this will give me a negative xy, x minus y, negative 2, plus y, x minus y, negative 1. Okay, negative 1. So you can actually simplify it before you want to do the second level differentiations. Okay, so you could write it to be negative xy over x minus y power 2. And then this one could be y over x minus y. This is power 1. If you want to make it power 2, so here you have to multiply with x minus y. Okay, x minus y. So negative xy plus yx minus y squared over x minus y squared. Okay, you can cancel this thing. So you left this negative y squared x minus y negative 2. Okay, so I write in this way because it will be easier later for me when I want to do second level differentiations. So this one also with respect to the x. So del square z del x square will be equals to negative y square, and then negative 2 x minus y negative 3. Okay, and then behind you have 1. Okay, minus. Okay, so for the second term you don't have anything, right? So you get 0. Okay, you get 0, and then x minus y squared negative 2. Okay, so this term will give you 0. Okay, so you will get 2y squared over x minus y power 3. Okay, power 3. Okay, as for the dz dy, del z del y. Okay, so we have to write it out again. This is xy. Okay, sy, then the equation is x minus y. Okay, so for the del z del y, okay, you will get this xy, this is negative 1. Okay, negative x minus y negative 1, and this is negative 1. Okay, and plus, okay, with respect to the y, so you have the x, and then x minus y negative 1. I'm using the UV rules, UV rules. Okay, so same like the previous one, you can simplify it. This is negative 2. Okay, plus the x over x minus y, you make it power 2, so you have to multiply the same term here. So negative xy plus the x squared minus the xy. Okay, so x minus y squared. Okay, x minus y squared. Am I right? Oh, here got negative, so this is positive. Okay. So it will be x squared over x minus y and square. Okay. This is the del z del y. So the del z square over del y square will be x square negative 2x minus y negative 3 negative 1. Okay, and for the y, this one will be 0 x minus y power negative 2. Okay, so this one will become 0, so we focus this as a 2x squared over x minus y power 3. Okay, right. So now we put it into the equation that the question asks us to prove. Okay, so the question asks us to prove this one. Okay, so we put here. So x squared del square z del x. Where is it? Let me copy it. Okay, so it will be 2y squared. 2y squared over x minus y power 3 minus y squared 2x squared over x minus y cubed. Okay, we have to prove that it is 0. So obviously they are the same, right? Okay, so it is equals to 0. So you can write that proven. Okay, proven. So because this one is give you 2x squared y squared, this one is also 2x squared y squared. Okay, so you minus them, so become 0. Right? Okay, so this is the questions B. Okay, for a question C. Okay, for a differentiable functions with the x equals to r cos theta and y equals to r sine theta, draw the T diagram. Okay, T diagram. Okay, so T diagram. So what is T diagram? So this is question C. Okay, not T diagram, tree diagram. Okay, tree diagram. So the x equals to r cos theta. Okay, y equals to r sine theta, and the f is the functions of x and y. Okay, so for the tree diagram, okay, we can see that we can say that we have a function f, and this function f is the variable of x and y. And for the x and y itself, it has a variable r and also theta. Right, okay? So x and y is over here, x and y. R and theta is here. Okay, for each x and y, you have the r and theta. So this is the tree diagram. Okay, tree diagram. Next, we have to prove that, okay, this is correct. This is what we have to prove. Okay, we prove that this is number 2. I will prove that the FR is equals to Fx cos theta plus Fy sine theta. Okay, we need to prove this one. Okay, so in order to prove this one, we need to find out what is the FR, right? FR. Okay, so F differentiate with respect to the R. Okay, so FR, okay, is equals to the del F del R. Okay, so it means that you have to form the chain rule equations. So your f functions has variables of x and also a variable y. Y. Okay, If you want to know the del r, so meaning that you have to multiply the del r over here, and this will be del x, and here will be del y del r. Okay, so fx is this one, right? And fy is this one. Okay, so you just need to find out this. Okay, del x del r. Okay, x equals to r cos theta. So the del x del r will be equals to cos theta. Okay, and for the y, it is equals to r sin theta. So del y del r is equals to sin theta. Okay, you can see the answer is over here. Okay, so you can write that one more time. Okay, the fr is equals to fx, right? So multiply with the cos theta, okay, plus fy sin theta. Okay, because this one is fx and this is fy. This one can put it here and this one can put it here. Alright, so this is about the question number 1.